remote method invocation in Java. Remote method invocation. Here you can see a remote method invocation, and here you can see remote procedure call. Working in architecture of RPC. Here RPC is analogous to a function call, extending a notion of conventional local procedure calling so that the procedure need not exist in the same address space as the calling procedure. Like a function call, the calling argument are passed to the remote procedure, and the caller wait for the response to be returned from the remote procedure. The client makes a procedure call and send the request to the server. As shown in this figure, the thread is blocked from processing until either a reply is received or it times out. When the request arrived, the server calls the dispatch routine that performs the request service and send the reply back to the client. After RPC call is completed, the client program continues its normal execution. Stubs are generated at static compilation time and then deployed to the client side, which is used as a proxy for client. Client side proxy acts as a mediator between the client and the broker and provides additional transparency between them and client so that the remote object appears like a local one. Proxy hides the interprocess communication IPC at the protocol level and perform marshalling of parameter values and unmarshalling of results from the server. Skeleton is generated by the service interface compilation and then deployed in the server side, which is used as a proxy for the server. Server-side proxy encapsulate low-level system-specific networking functions and provides high-level APIs to mediate between server and the broker. It receives the request, unpacks the request, unmarshals the method arguments and calls the suitable service, and then marshals the results before sending it back to the client. The sequence of events during RPC, the client calls the client stub. The call is a local procedure call with parameters pushed on to stack in the normal way. Client stub packs the parameters into a message and make the system call to send the message. Packing parameters is called marshalling. Client local operating system send the message from client machine to the server machine. Local operating system on the server machine passes the incoming packet to the server stub. The server stub unpacks the parameters from the message. Unpacking the parameters is called unmarshalling. Finally, service stub calls the server procedure. The reply traces the same steps in the reverse direction. Here you can see remote method invocation. Remote method invocation is a technology introduced by Java that allows invocation methods that are remotely located by the simply by simply calling them using desired interfaces. RMI technology allows us to distribute over business logic. That is making business logic available on a remote server, letting it to access to clients. RMI is often called RPC with object orientation. That is RPC, but with ability to pass one or more object along with the request. Object can include the information that will change the service that is performed on the remote computer, as delineated in this figure. For example, when a user at the remote computer fills out an expense account, the Java program interact with the user could communicate using RMI with the Java program in another computer that always had the latest policy about expense reporting. In reply, the program would send back an object and associated method information that would enable remote computer program to screen the user expense account data in a way that was consistent with the latest policy. User and company both would have the same would save time by catching mistakes early. Whenever the company policy changed, that would require a change to the program only one computer. RMI is implemented as 3 layers: stub and skeleton layer. The stub program represents the remote object and also acts as a gateway to corresponding skeleton at the server end. And the stub appears to calling program to be the program being called for the service. Remote reference layer. This can behave differently depending on the parameters passed by the calling program. For example, this layer can determine whether the request is to call a single remote service or multiple remote programs as in multicast. Transport connection layer. This setups and manages the request. A single request travels down through the layers on the one computer and up through the layers at the other end. RMI registry is a central repository keeping a track of all services being exposed from the current network. Since all client requests for services through the RMI registry, the location of the application or service is unknown to the clients, hence making the application location neutral. Here you can see in the remote procedure call here, this is the computer A client and computer B server. Client program, marshalling, client program stub and OS hardware are inside computer A client. Client program, skeleton and OS hardware here are inside computer B server. Here the client program calling procedure is connected to marshalling, and marshalling and unmarshalling are inside the stub here. Client program, the calling procedure is connected to marshalling through arguments. Marshalling is connected to OS hardware client network routings and interface. OS hardware, client network and routings and interface. In computer A, client is connected to OS hardware, client network routings interface in computer B, server via marshaled return. OS hardware is connected to unmarshalling in skeleton. Unmarshalling is connected to client program call procedure via arguments. Client program is connected to marshalling via return. Marshalling is inside skeleton, and marshalling is connected to OS hardware. OS hardware is connected to OS hardware in computer A client via marshaled arguments. OS and OS hardware is connected to unmarshalling in stub. Unmarshalling is connected to client program calling procedure via return. Here you can see the remote method invocation. Here you can see client host and server host. Server object interface, client program and server stub are inside client host. Server object interface, service skeleton and server object are inside server host, and RMI registry is inside RMI host. Here you can see one server object is connected to RMI registry via register server object naming.rebind. Here in step 2, client program is connected to RMI registry host via look for server object naming.lookup, and here step 3, RMI registry host is connected to client program via return service stub. Here step 4, data communication from service stub remote reference to remote reference layer. And here server host is connected to remote reference layer here, and here you can see server object is connected to RMI registry host, and client program is connected to RMI registry host. RMI registry host is connected to client program via return service stub, and client program interact with service stub. Service stub is connected to remote reference layer. Remote reference layer interacts with transport connection layer. Transport layer connection layer interacts with network layer, and network layer interacts with transport connection layer. Transport connection layer interacts with remote reference layer, and server host is connected to remote reference layer. Service skeleton interacts with the server object, and server object is connected to registry RMI registry host. Now this is the end of my presentation. Thank you very much for watching it.